Good morning, good afternoon, Mr. Stubbs' math class. Today we're going to look at something that we looked at on yesterday's Ed puzzle that was introduced, which is measures of center. All right, so if we look at our first definition here, measures of center, it says a measure of center is a way of blank the data by providing a central point of data. So what we're looking for here would be the word summarizing. Summarizing. All right. So to review there, a measure of center is a way of summarizing the data by providing a central point of data. All right, the next definition. The mean is a measure of center in which the blank of the data is taken. So that would be another word for mean, guys, and some of you may know this, is average. So another word for mean is average. And it can be found by finding the blank of all the data points. And that would be the sum of all the data points. All right. Number 2, blank by the number of data points. Dividing. All right, so let's review here. The mean is a measure of center in which the average of the data is taken. It can be found by finding the sum of all the data points, so adding them up, and then dividing by the number of data points. All right, the last one up top here, it says the mean can be thought of as determining the, and that would be the fair share. The mean can be thought of as determining the fair share. So average is another word for mean. All right, let's bump down here. It says Mrs. Hawkins asked students to divide the blocks into 3 different buckets. How many blocks would be in each bucket if they were shared fairly? Discuss your process for finding the fair share. All right, so here's our blocks. So we've got 2, 4, 6, 8, 10, and then 13, 16, 19, 22, 23, 24, 25, 26, and 27. So they're trying to divide these blocks evenly into 3 buckets. So how could they be shared evenly? Well, if you have 27, if we have 27 blocks and 3 buckets, in order to share fairly, each bucket would get 9 blocks. So each bucket would get 9 blocks, because if you take 27 and divide it by 3 for each of the buckets, you're going to put 9 blocks in each bucket for it to be distributed fairly. All right, let's look at the 3 problems at the bottom. Use your understanding of mean or average to answer the questions below. Number 1, the list below shows the number of points the Timberwolves basketball team scored. So we have 43, 72, 62, 57, 60, 49, 57, 49, 63, 55. So let's see how many data points we have. So if we count here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 is going to be our divisor. All right, but we need our sum first. So if we add up all of these numbers, we're going to get 567. All right. Now, if we take 567 and we divide it by the amount of data points that we have, which is 10, our mean, so our average, is going to be 56.7. So all I did was add up these 10 numbers and then divide it by 10 because that's how many data points there are to figure out the Timberwolves are averaging 56.7 points per game. All right, number 2, you can pause the video and try this one yourself. When you're done, press play and I'll have the finished work. All right, so if you added up these numbers, you should get a total of 256.8. 256.8. And then our data points are 1, 2, 3, 4, 5, 6. So you divide this number by 6, and you should have got 42.8. 42.8 is the average height of the inches of the people in line for the roller coaster. 42.8. All right, number 3. The following data set represents the speed of several cars as they pass over the Widow Falls Bridge. All right, so this one is a little bit different because we've got to order these. So if you see 55, so that means that there's 2 cars that are going 55. All right, so we got to list these so they make more sense. So 55, and then another 55. All right, and then we don't have any 57s, but we have 2 58s. 58, another 58. All right, so then we have 3 60s and 1 62, just to speed that process up. You didn't want to see me write those all out. All right, so this is called a frequency table. So 55, so we had 2 people going 55. So you got to write these out so you can see them. All right, then we can add them up. So how many cars did we have? 1, 2, 3, 4, 5, 6, 7, 8 cars. And we add those numbers up. We will get 468. And you can do that on a calculator, 468. And then you will divide that by 8, and you'll get 58.5 because there's 8 cars. And divide the total, 468 by 8, and you get 58.5 is the average speed. All right, let's go through the median. So we just did mean, now we're going to do median. So let's go through the median vocabulary. All right, so it says the median is a measure of center in which the blank of the data is determined. All right, so that would be the middle. All right. And it can be found by doing two different ways, 2 different steps to get the median. So you're ordering the data from blank to greatest, and we're going to determine the blank of the data set. So this would be least So least to greatest, and then determining the middle. And I'll go over this when I'm done here. And then the last one there says, if there is not one middle number, then find the blank of the two middle numbers. Put that in there. All right, so let's review. The median is a measure of center in which so median, middle of the data is determined. It can be found by ordering the data from least to greatest and then determining the middle of the data set. If there's not one middle number, then find the, that should be average. If there's not one middle number, then find the average of the two middle numbers. All right, so let's take a look at a couple of these. All right, determine the median of the data sets below. The following data set represents the number of menu items at 7 local restaurants. All right, so what we're going to do is we're going to order these from least to greatest. So 22, and then 24, and then 28. So 22, 24, 28, and then we have a 32, we have a 35, we have a 46, we have a 50. All right, so let's move those. All right, so now you can see these 1, 2, 3, 4, 5, 6, 7 numbers ordered from least to greatest. So now we can find that middle number that we're looking for. So when it's an odd amount of numbers, it's easy because the middle, so you're going to have, if you slash 3 numbers on the right or left and then 3 numbers on the right, you can see that 32, this number right here is, whoops, that turned them all, but 32 is the middle number. So our median would be 32, because 32 is that middle number. All right, if we look at number 5, the following data set represents the number of leaves that have fallen off several trees in Mr. Smith's neighborhood. So the first thing we must do is order these numbers. So that's what I want you to do. Order the numbers from least to greatest. So go ahead and pause the video and do that. All right, so we got them ordered: 37, 59, 62, 68, 85, 94, 107, and 92. And there's 8 numbers. So when it's an even, we got to take the average of the 2 middle numbers. And the 2 middle numbers here, so would be 68 and 85. 68 and 85 are the 2 middle numbers. Why are they the 2 middle numbers? Because you have 3 numbers to the left of 68 and you have 3 numbers to the right of 85. So when there's an even number in the data set, you got to take an average of the middle 2 numbers. Over here with the odd amount, see with 32, you had 3 numbers to the right and 3 numbers to the left and 3 numbers to the right. So we didn't have to find an average because there was an odd amount of numbers in the data set. So when you take an average of 68 and 85, that just means you're adding 68 plus 85 and then dividing it by 2. So the average, so the median there, you add 68 and 85 and then divide it by 2, you're going to get a median of 76.5. So it's a little bit more difficult when you have an even number of data points because you got to find average of the 2 middle numbers. All right, use your understanding of mean and median to answer the questions below. So we're going to put these together now. The number of items purchased by the last 5 customers at Gregory's Groceries is shown in the table below. So we don't have to order them to get the mean. We can just add them up and then divide by how many data points there are. So there's 1, 2, 3, 4. So there's 5 different people. So we're going to add these up. So go ahead and add these up and then divide them by the amount of people there are, which is 5, so we can get the mean or average. All right, so I divided mine up and I got a mean of 31.6. All right, now for the median though, guys, we've got to order these from least to greatest. So go ahead and do that. Press pause, order them from least to greatest, and see if you can find the median. So there's going to be 1, 2, 3, 4, 5. So it should be pretty easy. There should be an exact middle number. All right, so we got them ordered. So 15, 22, 23, 42, and 56. So there's an odd amount of numbers, which makes it very easy to find our median, which is 23. Because there should be 2 numbers to the left, and there should be 2 numbers to the right. So that would make this the middle number. So the median of this data set is 23. And then question C says, are the mean and the median close to the same value or very different from one another? What does this tell you about the data? All right, so I'm going to use my text box here. So the mean and the median are not very closely related. 31.6 and 23. There is quite a bit of spread between the data points. So the data varies greatly. All right, let me recap that. The mean and median are not very closely related. There is quite a bit of spread, and that word should be, oops. Got everything popping up here. So quite a bit of spread between the data points. The data varies greatly. 31.6 for the mean, 23. So that's 8.6 difference. So that's quite a bit of difference. All right, the last one's a little bit of a kind of a challenge problem. It says Mr. Harris states that the number on the cards below have a mean of 12. So in other words, an average of 12. What number is missing to make Mr. Harris correct? All right, so how many cards? We have 1, 2, 3, 4, 5, 6. Okay, so we have 6 cards. So in other words, whatever number, so x, whatever sum we divide by 6 is going to have to equal, so 1, 2, 3 is going to have to equal 12. Okay, so because all these numbers added up divided by the total number of cards, which is 6, is going to have to equal 12 because he's saying the average is 12. So what number divided by 6 will give me 12? All right, so if I multiply both sides by 6, I can find that x is 72. And that's the sum. Okay, that's not, 72 is not this. 72 is the total of all of these 6 cards. So if we add up the first 5, we get 18 plus 13 plus 12 plus 14 plus 11 is 68. And we know the total sum is 72. So if we do 72 minus 68, we are going to get 4, which means that last card here would be, so that's last card here is 4. Because you add all these up, and if you put 4 with this card, that makes Mr. Harris correct, where you have an average or a mean of 12. All right, so we're done here. So make sure at the bottom of this sheet you summarize today's lesson and complete the exit ticket on today's agenda.